Hi, my name is Wojtek Erbetowski. So I'm bringing the unpopular topic of documentation. Probably we all love to have and use documentation, especially if it's well written and maintained. We usually hate to do it. So for starters, and I don't have too many slides actually, I just have one more. So it should be fast, I guess. To begin with, actually, I'll share a story of how I had to first write a documentation. So you can imagine this junior developer in his first company. Actually, I can still remember my very first task I was given. So the company I was working for back then was supporting this contest. And jury during that contest were actually walking across the gallery and looking at different expositions there. And they used, so now you can figure out how long ago it was, they used palm tops to vote. They had, and we were building the application for palm tops which they used for voting. And they didn't cheat, they didn't think about that, we didn't need to secure that application, but during the previous contest, they were actually making mistakes during logging to the application. They just had IDs, they were too similar, so it happened once or twice that someone was actually voting as someone else by mistake. So you can imagine that was a terrible mistake. But this edition, the company wanted to do it a bit better. Still no authentication, but hey, Wojtek, could you actually write a piece of code to generate IDs so they are not too similar, so it would be very difficult actually to log in as someone else by mistake? So I thought, yeah, absolutely. So I actually enjoy live coding sessions. So why not? And you'll be able to see more or less the real thing, how I implemented it back then. So the first method I used to more as just a utility so I can go a bit faster. The first method is the one that I have to implement. So I want to generate those IDs, and the parameter says how many I need to generate. So let me start with maybe initializing the result that I will return in the end. So let's go with, what would it be? A list of strings. So this will be the actual result I want to return. So new array list, that's great. So in the end, after I do everything, I want to pretty much just return it. Okay, so I now have those like constraints, now the whole body. What could we do? Well, think about it, as a junior developer, not many patterns at my hand, so I'll just write a for loop. While I don't have enough, let me go with size is smaller than count, I will want to add another one. So, great, how can I add it? Well, maybe I could actually have a new string. So, generate a random ID, just a small method to generate a new one. Let's make it a variable, new ID. Great. So now I would like to add it, but only if it's not too similar to something I already have, right? That's super simple. So let's go for the IDs that I already have in the result collection, and let's check the distance. So if the distance between the new one and the one that I have already in the collection was too small, and by that, let's say it's smaller than at least 2 places that someone would have to switch to jump into another ID. Well, let's just skip this, right? And after we, and if we didn't skip by now, then let's just result add the new ID. So we could, right, that's a very good. You're way smarter than I am. This is why a person right here saw the bug already pretty fast. That's cool, right? Actually, this is almost the code I have written about a decade ago with this single change that actually I didn't use too many methods. I like them having all in one method. So here's the code I used to generate the new string just by random, making it a string, and the distance, well, that was something I have counted here as well, so I was iterating through both of them. So more or less you can actually see the code I have created back then. So I didn't want to have a bug in it, so I wrote something you would call now a unit test. But it basically was just a main method which generated a lot of those IDs and checked the distance between them. I have this test right here, just as a regular unit test. Cool. And it's being executed and it passed, right? So it must be working as well. Well, of course, you have some random things. You have different terrible ideas in that small piece of code. So the problem is actually the amount of IDs I tested it against was too small. And I was lucky to pass that, right? And just like you noticed, the bug in the code right here is that whenever I want to continue to skip the while loop, I do that only within the for loop. So basically, I can have even identical IDs, and it would still pass, right? A terrible piece of software. Anyway, I was asked right after writing that to document it a bit, to write several maybe sentences or something about how the function works, right? And many of you remember that from the old days, or some of you actually work still with a code like that. Well, how could we document that? I just looked at the code around, so like, oh, Javadoc, okay, great, I'll write it down. Great, now it's documented, right? I added some information to the method itself. Did it improve anything in any way? No, I just added some additional lines, right? But another comment we usually do is just we actually comment single lines to express why do we need that, right? So result actually is pretty expressive. What we could say right here was like, do not add this one, right? It doesn't only solve the code, it also lies in this place, but this is a way that we usually deal with too complicated code by different comments in code, by trying to help out other developers. And of course, it was a long time ago, or maybe it's still happening for some legacy projects, but then clean code comes out, right? By Uncle Bob, by Robert C. Martin. Basically a single person, a huge authority which promoted clean code, object-oriented programming, small methods, readability. So of course, developers learned actually that comments are not a good way to fight with unreadable, unclean code, right? It's the code itself that should be documented enough that we can easily understand that. And it would require here plenty of things, actually. One of them would be to put the random parts somewhere completely else so that we can test without any random parts. Another one would be actually, even to start very early, this method is not named correctly. It doesn't say its real purpose, which is to generate unlike IDs. This is what it does, actually. But After we learn how to write more readable code and how to tackle this complexity in a way better way, we actually stopped doing documentation at all. We didn't see a lot of point, or we even thought like this is a negative thing to add. So if you look at this code, even if you could imagine the most readable, perfect scenario in here, then you can take a look, and then you can already see what it does almost instantly. You don't have to read everything. You can just see those couple of lines saying like, okay, so I'm adding a new ID. If it's far away, then return the whole array. The problem is, whenever someone else comes to and reads that code, they're lacking a lot of information. They know exactly what the code is doing. They have no idea why. You have a lot of context here. You know about the contest. You know about the jury, which needed different IDs. And how did you decide to implement that, to give them the functionality? You know a lot of context which helped you in choosing the implementation, and the maintainer might actually have a better idea to generate those IDs as well. But they have no idea why was it created like that. So it doesn't, it wouldn't explain its purpose in the end. And this is a great way to actually help future maintainers or our colleagues or open source community to actually tell them why. So I'm not evangelizing, commenting on readable code in any way, but when I started to think about why is my documentation always so bad? Why no one wants to read it? Why it's so unimportant that I don't want to write it at all? Then for the very first time, I asked myself, well, why do I want to have it in the first place, right? And I felt extremely stupid because I never asked this simple question before. But if you ask yourself why, then instantly you actually come up with another question. Okay, so who will be using that, right? Whom will be the person I write it for? And after that, you can ask, why does the person need that? And how can I help in that particular situation? So do you know who else asks questions like that? Do you have like a person, a job, which tries to answer questions like that on a daily basis? Any ideas? So for me, that's extremely similar to what UX designers are doing. User experience designers are trying to figure out the needs of our clients, of our customers, their whole flow. What are they looking for? What are they trying to achieve? How can we help? How can we do that faster and easier for them to improve the solution? So I'm not trying to reinvent the wheel. I actually took several things from their daily work to improve the process. And one of them, the first one, is a pattern called, or maybe a tool called personas. What they do, not to tackle every single customer or have too many categories, they actually come up with just several different personas to categorize them. So let's say who would be a good persona in our project. And usually we say like, okay, that's like a new developer joining the company. This is pretty obvious, right? They have to understand the code, they have to figure it out. It's not always that obvious. So in this particular scenario, this is what I sometimes do, or maybe even pretty often. I try to install a library I use on a daily basis, right? Either it's Gradle, it's or Yarn or whatever. Let's use pip even for that. Oh, great! I have this command right here. So I want to install a library called Factory Boy, right? I've used it before. I liked it. I'm starting a new project. I want it here, right? Oh, there's no such library. That's the error message. Okay, right, so I definitely might have misspelled or something. How can it be not there? So I'm Googling it out. Oh, great. It's the first result, at least for me in Google. So let me see. What's here? Okay, this is how you use it. I know that already. Some links. Download, great. It's factory underscore boy. Yes, great. My need was just solved, right? So it's not always someone who learns about things, not someone new, but someone who actually can try to find a particular information. So when we have, maybe let's go back here. So whenever we have already a persona that we know how this person, what this person looks like, what is their knowledge, then we can figure out why are they being here. So there's another tool called the user journey. And this tool aims to map the whole flow of the user and figure out maybe a particular place that we can improve, right? So another example of something I do on a daily basis or maybe weekly basis, I go to GitHub, but not a particular repository, just GitHub. And what you can see here, you have this wall of activity. So I'm following a lot of even speakers here at this conference. I always want to know new cool libraries I'm missing out, right? So what's that? It's NEDB. Sounds awesome. Wow, please help me. So what is NEDB? The JavaScript database, embedded, persistent, or in-memory database for Node.js, blah, blah, blah. Okay, great. No binary dependency API is a subset of MongoDB. Run away fast, right? Actually, this is extremely useful. It was enough for me to read this one sentence, and I know I probably can just ignore this library. I don't need it. I don't want to use it. And this is my goal, actually, to find out as soon as possible that I can ignore the whole thing. It's not always so clean, so I've picked another one. Extremely popular project, Redux Saga. I'm missing some images here, but if you can read that. Redux Saga is a library that aims to make application side effects, blah, 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 easier to manage, more efficient to execute, simple to test, and better at handling failures. Well, reading even the rest of the paragraph doesn't give you the feeling, what is the library about, even? You have to spend more time, way more time to figure it out. So in this particular scenario, I wouldn't be satisfied with that piece. Okay, so if we even know already who is going to read the documentation and why, what is their need, there are lots of different issues with the documentation, right? It's not always the lack of documentation or inaccurate. What would be your number one problem with the documentation? You don't have any problems with documentation, correct? Sorry? Searching for content, okay, great. What else? Well, usually what I get, and this is what I find myself disturbing as well, it's out of date. It's lying. It tells maybe some kind of maybe it has some kind of information that used to be true, or maybe even wasn't ever. And the problem is actually it's completely out of date. And I just thought it has to be like that, right? You just write some docs, and then you change code. You don't remember that there were docs for this particular feature, so you don't update them, right? A regular thing to do. But at some point of time, I've been working with Gradle. And that's a build system for JVM. I loved the project. I loved working with that. But at some point of time, I just thought like, hey, they have a great documentation, and it's a living one, right? Let me go to Gradle or .docs/docs. And here's something I mean, like let's go with Java applications, and if you scroll, you can actually see a lot of different code samples. So whenever I just copy and paste that, it works. I've never found a single one that would have like a spelling error or would be out of date. How come? And I felt like it's an extremely disciplined team that develops that, right? That they review the documentation constantly and treats that. But that's not what happened. When I looked into the source code, actually, every single piece of code in that documentation is being executed and tested whenever tests are being executed. And how does this happen? Actually, let me show you this one. It should be here. They use the format called Asciidoc, vim.docs, Asciidoc, right? And this is like a super simple tool, something like Markdown, maybe a bit more sophisticated, right? So you can do what you can do. Just like, oh, maybe let me open that in the IDE. It will be more readable. Sorry. It's right here. So you can write several sentences, mix that with code samples, and you can build an HTML out of that. So I can use just Asciidoctor. Great, that's the command. And let me open it. Great. So this is what I can do. The documentation being built, executed. And this is what I regularly do for my code, right? So the functionality it describes is a simple age validator. You can see it validates human age in here. Oh, sorry. Okay, great. So so it validates an age. The problem is, sorry, I used the wrong version. It was supposed to be like that. So yeah, so my documentation by mistake already was lying. So it's supposed to tell you whether an integer you're giving this method is a proper human age or not, right? So you can see the implementation right here. Extremely simple, probably useless. And the specification right here. So this is a very, very similar code to the one that we saw in the documentation, right? Okay, so it was my mistake. That was a general age validator. So what we want to do actually, we have this change request, which tells us, well, it should be, what you should do is actually test against human age, not only age in general, right? So what you're going to do is, let's change this part, so then I can have a red test first. It executes. Let's see if it fails. I hope it does. Great, okay, so that wasn't true anymore, so now I can go to the implementation. Let me fix that, and age is lower or equal to, what's a proper value, 125? Probably no harm there. But Google promises to change the upper boundary fast, so. Okay, so what happened right now was I've changed the test. I'm a really good developer. I started with changing the test. I went to fix the implementation. Now I can commit that and push that. The only problem is I've never updated documentation at any point here. So what Gradle does is actually they go to, they write the documentation in a slightly different way. They go with, here it is, with just files from the file system, which they are linking to documentation. You can do that. You can link the actual source code, whatever the technology is. It's just a text file for Asciidoctor. So let me regenerate, and you can see that now you have this real code here. But whenever you build your application, it will be executed, it will be tested. The problem is that you have a lot more information that you want to in your documentation. So a lot of projects are doing it right now. They tell you, like, just check the tests. They will show you how the API works. And the problem with that approach is that tests are not optimized for discovering new APIs. And they never will be, because they will still have to check edge cases and different patterns, right? They are not being optimized to be read. So another thing that we could do here to improve is actually, let's use just a piece of that file. Okay, let me just use this one so I can cheat a little bit. Cool. So now I'm putting those tags as comments in any language, any technology that supports comments, so that's pretty easy. So it won't change my implementation, but whenever I rebuild the documentation right now, I can see that's readable enough. Yeah, the screen is pretty huge. Now you can see that only the fragment that you want to include in your documentation will be there. If you want to have just a subset of your test, no problem. Just change where the tag is being located. Bam. There your perfectly readable documentation. Okay, but code itself and methods aren't the only place that we want to document, right? It's nice that we can execute all of those samples. Oh, maybe just one more thing I've missed here, that we have something completely new right now. If we have those tags, we can see that this fragment is actually being used in the documentation at all. So whenever we change an implementation, we can see the test failing, and then inside of that test, we can see, oh, someone uses that in docs. So let me find this piece, right? I can go to the documentation and figure out whether the description itself is still valid. So now I can go with human age right here. So I can fix it as I go because I have a link in the opposite direction. Right. So despite of documenting just our code and methods, APIs are another thing we constantly want to document. And we create different documents maybe for that. We try to generate documentation, but it's pretty unreadable usually. So someone wanted to figure out this problem some time ago. And first of all, they created a tool that can auto-generate your API documentation from your code. It was a small library for Jersey, for JAX-RS in Java. And then it evolved, actually. People loved it. They used that with a variety of different languages. And the file that you generate out of your code was so popular that they actually tried now to standardize that. They moved from JSON to YAML. And the libraries used to be called Swagger, and the format as well. And I guess it didn't sell too well in enterprise. So they changed the name to OpenAPI. Sounds a lot better, I guess. So, Bulldogs, here. Let me show you actually, is the font big enough? Hope it does. Maybe just to be safe. So you can actually have these files which describe existing APIs. It can be your API, but you can also describe someone else's API. It doesn't have to live together with your service. What this file looks like, it has a bunch of meta information here in the beginning. So I'll just skip that and move a bit forward to the most important part. So here you can see paths. And paths tell you about different endpoints this HTTP API has available. Every single path can have several methods, like get, post, head, options, yeah, pretty much everything. So you have to describe method by method. You can give it some description. You can tell what the parameters are, like either path parameters, query parameters, anything you would like to use with that API. And once you have that described, this file is supposed to be readable and writable by both humans and machines, like this perfect place in between. So as you can see, it's still pretty readable. It has some responses, but how could you use that as a machine? Well, one of the things you could do is like you could generate a whole client library out of it, not to maintain it by hand. You can just generate a project. And I should have that here, yeah, a bit bigger. So it just generated a Gradle project with all of the client libraries. This is more or less like what it looks like. It's not perfect, it's still generated. But how can you now play with the API? Well, let me just create my class to play around. So you have to make an instance of the API, and now you can play with it on a Java methods and API level instead of HTTP level. So it hides all of the HTTP traffic by single methods. And this is Sandbox's activity. This is one of the paths described in the Swagger YAML. Right? I think it has several parameters. So what would be a best way to do it? Right. Exceptions. Oh, maybe I'll just add this one, right? So now I could use a simple method. But the real gain here is not only having simpler code or not having to write the HTTP layer, not even failing tests. Because whenever I will change this file, so whenever a new version of the API comes up and someone updates the YAML, which can be our internal API, so it could be even us, we can regenerate the whole project. And what happens right now is way better than a failing test or any kind of linting. We get a compilation error of this parameter no longer being there, right? That's pretty amazing. So you can have a documentation both readable and executable. But the great selling point from Swagger, I should have it somewhere in here, is the UI it gives you. So another tooling on top of that file is the UI you can have based on that single file. So you can see a lot of methods here being described. Let's go with a pet for a single, let's draw slightly bigger. And not only you can read the documentation, but you can, it's interactive, you can play with it. So you can say, okay, try it out. Here's the body I want to send, and let's execute it, which will hit the actual API. If you want to discover, learn, and see how it works, then you can just use this console. You can embed it in your own service as well, which is I love using that, right? So the last tool I wanted to show you is actually maybe how we eat our own dog food at Codility, where I work. And this is a small library we developed for ourselves. We use React.js to develop front-end components. And if you don't know the library, actually, the biggest promise is actually to it tells you use small components that you can put together to build bigger functionality and not repeat yourself. But you don't have to extend and make huge components out of it. You can just compose them together and reuse them heavily. That's a great one, but the problem is that you're constantly creating components. No one else knows that you have just created them, so they create similar components instead of reusing them. So we needed a way to discover them, but we couldn't support the documentation for all of them. So we've built a pattern library for ourselves. You can see the whole thing being built here. So this is the effect. It actually scans for components within our code. And for every component that there is a docs element as well, it will parse it and execute it to build this UI. So you can see a list of components on the left hand, and here's some examples. So if you want to build a piece of documentation, you actually do that with this code right here. So you can go with, okay, so I'm describing my component. This is the description and the properties it takes, and then some working real-life examples that will be executed when building this documentation and entering these sites. So what does it look like in the end? Well, you have some examples right here. The iterator component, you can see the code that creates it and a way to use that right here. And right above that is the living working component. It's JavaScript, so it's a native environment for that piece of code. There's no magic here. If you scroll down, you have more usages right here. So you can already see those interactive components, and not only how the code looks like, but what the author thought of this component, of how to use it, how to play with it when she or he created it, right? So that's pretty powerful way. And every time you enter this site, you build the documentation, it's still being executed. So this talk was actually about documentation in the self-documenting world. But the big idea is to both know how to build documentation and why. And for how, it's always best to have executable, runnable documentation that lives together with your code. And for how, unfortunately, you will have to discover what your company, your team needs exactly, because there's no silver bullet there. Okay. I'm happy to take any questions. So there goes my second slide. Any questions? Right, if you have any or would just like to talk about different problems in your documentation, I'll be right here for several more minutes.